The history associated with developing FAD tools is quite interesting. It started back in the early 1970s when the electric utilities throughout the country decided to utilize tubular steel poles in lieu of lattice steel structures. The thought process at the time was that the tubular steel poles were more aesthetically pleasing than the steel lattice structures, and therefore they would be able to get these new transmission lines more readily permitted and allowed. We got a phone call from Duquesne Light, our local utility, asking us to design foundations for their new tubular steel pole line. So we did an immediate literature search to determine what are the methodologies that are available in the literature to design drilled shafts for tubular steel poles. Our search indicated rather rapidly that there was very little available methodology. Therefore, we had to use our engineering judgment to design this initial set of foundations for Duquesne Light. After the project was completed, we realized that our designs were very conservative, meaning that they were quite large, and therefore we thought it might be appropriate to contact the Electric Power Research Institute in Palo Alto, California, to establish whether or not they might be interested in providing funding to conduct the research into development of new technology. We also contacted a number of utilities to determine their interest in being involved in the development and execution of full-scale load tests of drilled shafts subjected to single pole type loading conditions. We took a trip to Palo Alto and presented the thought process to the managers at EPRI, and they agreed that it would be a worthwhile project to pursue. So we initiated the project in the early 70s, and we also contacted, with EPRI's permission, a number of utilities to run full-scale load tests in their service areas. And we involved the utility staff in both the development of the analytical model as well as in the conducting the full-scale load tests. As a result of the analytical work and the full-scale load testing program, we developed an initial program called PADDLE. And that program was distributed to the funding utilities and utilities of interest throughout the United States. The next phase came about when we realized that the program had a limitation in that it was only designed for the design of, was only utilized for the design of drilled shafts for these large tubular steel poles. And many of the utilities were interested in direct embedding these poles. Direct embedment meaning they would drill a hole, drop the pole into the hole, into the shaft, and backfill the annulus with appropriate backfill. Therefore, that was the next phase of development, was to include the design of direct embedded poles as another module to PADDLE. Also, the initial development involved just total soil subsurface conditions. And in many cases, of course, sites would involve soil at shallow depths and eventually hit rock. And we needed to take a look at how we might take the models that we had and modify them. So that led to the next phase, to develop PADDLE so that it could deal both with soil, all soil, as well as soil on top of rock subsurface profiles. Subsequent to that, the utility industry realized that the single pole structure was a very important structure. However, they realized that they were also building H-frames, tubular steel H-frames, wooden H-frames. They continued to build the steel lattice structures, and they decided that they should consider now adding modules to the original PADDLE to be able to design the foundations for H-frame type structures as well as tubular steel structures. This is what led to the development of HFAD for the design of drilled shafts and directed embedded poles for H-frames, and for the development of TFAD, which were for drilled shafts for four-legged lattice towers. We now are working, of course, to make this program available throughout the United States. We have a licensing agreement with EPRI to do that, and we are also looking at the development of a users group in the near future so that the users of the program, of the FAD tools program, can get together periodically to discuss common problems and what additional modules might be appropriate to develop into the future.